Today's video describes how to predict redox reactions and how to determine if the reactions are spontaneous. Before you can predict a redox reaction, you need to determine which entities are present in the solution. Be sure to consult with the solubility table and follow the rules for dissociation and ionization in water. You will then use the table on page 7 of the data booklet to figure out which entities will be involved in the redox reaction. In this example, a strip of tin was placed in a solution of silver nitrate. The solution will have solid tin, silver ions, nitrate ions, and water. Use the table on page 7 to see which side of the table you can find each entity on. You should be able to find solid tin on the right side, which means that it is a reducing agent. Silver ions will be on the left side, so they are oxidizing agents. And water is on both sides, so it can be an oxidizing agent or a reducing agent. In step 2, we determine which of the entities is the strongest reducing agent by seeing which of the reducing agents is lower on the table. We can also determine which of the entities is the strongest oxidizing agent by checking which oxidizing agent is highest on the table. The strongest oxidizing agent and the strongest reducing agent are the only entities involved in the redox reaction. Using the half reactions from the data booklet, write the half reactions from the strongest oxidizing agent and the strongest reducing agent. Balance the electrons from the two half reactions to write the net ionic equation. In step 5, you can predict if the reaction is spontaneous by locating the strongest oxidizing agent and strongest reducing agent on the data table. If the strongest oxidizing agent is above the strongest reducing agent, like in this example, the reaction is spontaneous. If the strongest oxidizing agent is below the strongest reducing agent, the reaction would be non-spontaneous. This example follows the same 5 steps, but it is more complicated because there are more entities involved. Tin 2-bromide and acidified sodium dichromate solutions are combined. There would be tin ions, bromide ions, hydrogen ions because the solution is acidified, sodium ions, dichromate ions, and finally water because these are solutions. Each entity is located on the data table to determine if it is an oxidizing agent, reducing agent, or both. The strongest oxidizing agent is identified by choosing dichromate and hydrogen. Because these are together in the data booklet's half reaction, they are both the strongest oxidizing agents. Tin ions are the strongest reducing agents. Write out the half reaction for the strongest oxidizing agent and strongest reducing agent. Balance the electron in the half reactions by multiplying the oxidation half reaction by 3. Combine the two half reactions. The strongest oxidizing agent is above the strongest reducing agent in the data booklet, so the reaction is spontaneous. It is important to include all entities possible when listing entities in step 1. If there are solutions or anything is called aqueous, remember to include water. If solutions are acidic, include hydrogen ions, and if solutions are basic, include hydroxide ions. Some oxidizing and reducing agents only work if they are combined, such as permanganate ions and hydrogen ions. There are also several entities that are both oxidizing agents and reducing agents. Be sure to be very thorough when assigning them as one, the other, or both. Disproportionation is still possible in these scenarios. It will typically occur when the entities are located on both the oxidizing and reducing agent side of the data table. This example with molten chromium 2 chloride shows how to predict disproportionation reactions. The only entities are chromium ions and chloride ions because the solution is not aqueous. The chromium ions are both the strongest oxidizing and strongest reducing agent. Write the half reactions from the data booklet. Here the electrons from the two half reactions are balanced, and then their reactions are combined. The oxidizing agent is below the reducing agent in this case, so the reaction is not spontaneous. Please complete the October 11th quiz.